The James Webb Telescope has captured the clearest image of Proxima B in history, unveiling stunning revelations about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the secrets of Proxima B and investigate whether it might be the next Earth. We venture into the vast expanse of space, where a fascinating planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin, Proxima B, located 4.2 light-years away. It is cloaked in mystery and could one day resemble Earth, with oceans and life flowing across its surface. But wait, there's more. Proxima B isn't alone in its system. It has a single companion, Proxima Centauri SE, which could reveal even more secrets. Perhaps there's another companion we haven't found yet. The mystery doesn't end there. Proxima Centauri emits a similar amount of energy as Earth receives from the Sun, which raises intriguing possibilities. Could there be water on Proxima B's surface? Could life, as we know it, exist beyond our solar system? As we venture farther into space, we encounter a whole universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the Milky Way galaxy alone, the potential for exoplanets is limitless, some of which even wander through space untethered to any star, like radical pioneers. Among them, Proxima Centauri B stands out as a truly shocking and puzzling planet, with a year lasting just 11.2 Earth days. Its distance from its star is much closer than Earth's distance from the Sun, meaning one side of the planet is constantly bathed in light, while the other remains in eternal darkness. Now, let's examine Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and B, 2G and K-type stars that appear as one in the Centaurus star group and are the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 4.24 light-years from the other two stars, making it the closest star to our solar system. The name Proxima Centauri means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being the closest star to us, Proxima Centauri is invisible to the naked eye due to its apparent magnitude of 11.13, which is beyond the limit of human vision. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. While they may not emit much light, the convection process at their cores keeps them shining for trillions of years. In fact, Proxima Centauri will remain a principal sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri is still debated. For one, it's a flare star, meaning it undergoes regular, sometimes extreme, flares. As a low-mass star, its habitable zone would be much closer than the Sun's, likely somewhere between 0.23 and 5 Australian dollars. Yet, even this zone may not be as accommodating as it seems. Proxima B may not have a stable atmosphere, which is essential for maintaining conditions suitable for liquid water on its surface. Without this stability, life would be vulnerable to space weather, making it incredibly difficult for life to thrive. So, while Proxima B could seem Earth-like on the surface, it's far from being capable of supporting life. Still, many researchers continue to hold hope. One tool that has caught the attention of astronomers is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and is poised to help determine if life exists on Proxima B. However, as with everything in science, things are never as simple as they appear. Some adjustments were needed to ensure the James Webb Telescope could deliver accurate images. As Abby Wind, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also remit that light as infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation on the planet's surface and search for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet's atmosphere isn't suitable for life? The presence of an atmosphere doesn't guarantee life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere far denser than Earth's, resulting in extreme heat that would make life impossible. the mission to uncover the truth about Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are many factors to consider. With costs mounting, space researchers feel the pressure to find ways to examine planets like Proxima B. Much is at stake. However, the rewards are even greater. The opportunity to glimpse the unknown and unravel the mysteries of a system that could harbor life is a goal any serious scientist would pursue. But could we ever travel to Proxima B? It's the closest exoplanet to us, which makes it a captivating possibility. It's almost like exploring our own backyard. Even more fascinating is the fact that it's almost the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it a practical target for our quest for life beyond Earth. At just 4.2 light-years away, it's an ideal candidate for interstellar missions. Now, consider the possibility of exploring this Earth-like exoplanet. However, we can't go there just yet, but it's certainly on the radar for future missions. As technology advances, space travel becomes more accessible. Proxima B remains one of the most exciting prospects in space exploration. However, it's no simple task to get there. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. That said, a proposal has been made involving solar sails, ultra-thin sails that could be used to accelerate a spacecraft toward the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. With expected speeds of 10% to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration, offering a renewed sense of hope that we are not alone in the universe. The James Webb Telescope is a marvel of modern technology, capable of taking us all the way back to the very beginning of the universe, 13.7 billion years ago. This is the carefully preserved secret. The farther an object is, the longer it takes for light to reach us. This means the James Webb Telescope can observe objects in the universe farther away than any other telescope before it. Furthermore, it can detect these objects in longer wavelengths of infrared light, allowing us to see distant stars with greater clarity than ever before. And here's something even cooler. This incredible technology can provide insights into the possibility of life on other planets like Proxima B. However, like everything, there are some notable limitations. The presence of an atmosphere doesn't necessarily guarantee life. Proxima B could be like Venus with a thick, toxic atmosphere. But get this, the James Webb Telescope can detect such conditions if they reach a brightness of just 5% of the planet's dayside. While 5% may not seem like much, it's quite significant when dealing with a star that is mostly dimmer than our Sun. If Proxima B has intelligent life, they may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, some being enormous gas giants, while others resemble our own Earth. One type of exoplanet that has garnered the attention of space researchers is the gas giant. These planets are similar in structure to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed superjupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching environment with temperatures high enough to melt metal. Imagine being able to observe such a planet up close, with its violent storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres difficult to study from afar. However, we shouldn't overlook Earth-like exoplanets, those that resemble our own Earth. These planets come in various sizes, from smaller than Earth to twice its size. There are also super-Earths, which have masses greater than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets discovered recently is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a potentially Earth-like exoplanet, meaning it could actually support liquid water. Scientists believe it may be habitable, especially considering its proximity to its host star. Proxima B's potential to support life has made it the subject of intense study. Despite sitting within the habitable zone of its parent star, many uncertainties still surround its atmosphere and overall habitability. One of the major challenges for Proxima B is the intense solar flares emitted by Proxima Centauri. These flares could strip away the planet's atmosphere over time, making it more difficult for life to thrive. Much like the early stages of Mars history, the magnetic field of Proxima B would play a crucial role in protecting the atmosphere. Without this protection, the planet could face harsh conditions that prevent life from developing. Despite these obstacles, researchers remain hopeful that advancements in technology, such as the James Webb Telescope, will continue to provide new insights into Proxima B's atmosphere and whether it could contain the essential conditions for life, such as liquid water. The telescope is capable of analyzing the planet's atmosphere composition, looking for key chemicals that could signal biological activity, such as oxygen, methane, or carbon dioxide. Even if Proxima B is not habitable, the discovery of so many potentially Earth-like exoplanets in the habitable zones of distant stars opens up new possibilities for finding life beyond Earth. The search for exoplanets is one of the most exciting fields of exploration today. The vast number of stars and planets in our universe suggests that life may be more common than we once thought. And although we are far from reaching these distant worlds, the quest for knowledge about our universe is an endeavor worth pursuing. For now, Proxima B remains one of our closest and most fascinating focal points in the search for life beyond Earth. As technology continues to advance and we dive deeper into the intricate dynamics that make a planet habitable, we draw one step closer to answering one of humanity's oldest questions. Are we alone in the universe? The study of Proxima B and other exoplanets is just the beginning, and the next few decades could bring great discoveries that will shape how we understand life in the universe. As we continue to push the boundaries of space exploration, one of the most fascinating aspects of studying exoplanets like Proxima B is the possibility that life could exist in places far beyond our own solar system. The discovery of such planets expands our understanding of where life might thrive. Proxima B, in particular, has captivated the imagination of scientists due to its proximity and potential for habitability. However, understanding whether life could truly exist on this distant world requires more than just looking for water or suitable temperatures. One area of research that has gained significant attention is the search for biosignatures, which are chemical markers that might indicate the presence of life. In Earth's atmosphere, gases such as oxygen and methane are produced by biological processes, and their presence in the atmosphere of an exoplanet could suggest similar biological activity. The James Webb Space Telescope, with its advanced capabilities, is designed to study the atmospheres of distant exoplanets in unprecedented detail. By analyzing the light that passes through the atmosphere of Proxima B, it can detect the chemical composition of the planet's atmosphere and look for these key biosignatures. The challenge, however, lies in the fact that the presence of certain gases does not always guarantee the existence of life. For example, oxygen can be produced by natural processes like water splitting under the influence of ultraviolet light, and methane could come from geological or chemical processes unrelated to biology. This means that detecting these gases is only one piece of the puzzle. Scientists must carefully evaluate the context in which these gases exist and whether their concentration and composition suggest biological origins. In addition to detecting biosignatures, astronomers also need to understand the dynamic environment of Proxima B. As a planet orbiting a red dwarf star, Proxima B faces unique challenges. Red dwarf stars are known for their unpredictable flare activity, and these flares can significantly impact the atmosphere of nearby planets. They can strip away the atmosphere over time, especially if the planet lacks a strong magnetic field to protect it. This is one of the major concerns regarding Proxima B's habitability. Without a stable atmosphere, liquid water could not exist, and conditions would likely be too hostile for life to thrive. Moreover, red dwarfs like Proxima Centauri are subject to periods of high stellar activity, which might include flares that last for hours or even days. These flares release massive amounts of radiation that could harm any potential life forms. However, this doesn't mean that Proxima B is completely inhospitable. If the planet has a strong magnetic field, it could offer some protection from these solar flares, much like Earth's magnetosphere protects us from harmful solar radiation. Another fascinating aspect of Proxima B is its orbit and rotation. Its year lasts only 11.2 Earth days, which means it orbits its star much closer than Earth does to the Sun. This tight orbit places it in what is called the habitable zone or the Goldilocks zone of Proxima Centauri, an area where conditions might be just right for liquid water to exist on the surface. However, due to its close orbit, Proxima B is likely tidally locked to its star, meaning one side of the planet constantly faces the star, while the other side remains in perpetual darkness. This could create extreme temperature differences across the planet, potentially making the conditions on Proxima B more difficult for life to survive, unless a mechanism like strong atmospheric circulation or a water cycle could help balance the temperatures. Despite these challenges, the discovery of potentially habitable exoplanets like Proxima B has reignited the search for life beyond Earth. New technologies, like the James Webb Space Telescope, offer hope that we may be able to answer the age-old question: are we alone in the universe? As we continue to refine our ability to detect exoplanets and study their atmospheres, we move closer to understanding what makes a planet truly habitable and whether life can arise in places we never before imagined. Proxima B is just the beginning, and as technology advances, the next few decades will likely yield even more exciting discoveries in the search for extraterrestrial life.